Alrighty, so we're going to continue on with our circles unit. Today we're going to look at chords and arcs and the special relationships that go on with those. And so we got to first define what a chord and an arc is, because that will help. Because if we don't know what they are, then this will be kind of hard to do. These definitions are also found on that reference page dictionary thing that I sent out yesterday. So we can define a chord as a segment with endpoints on the circle. Okay, and then over here in this blank space, we'll write out some examples of chords and arcs. But in general, a chord is a segment that has its endpoints on the circle. And generally, it doesn't go through the center. If it goes through the center, then we call that the diameter. Okay, but otherwise, it's a chord. An arc we define as a piece of the circumference of the circle defined by two endpoints. So remember, the circumference is the distance all the way around the circle. An arc is just a piece of it, and it's defined by two endpoints that are on the circle. Okay? It has a special symbol that goes with it for naming, but we'll look at that in a minute. So let's write out some examples of chords here. And there's only two given to us. We could make other ones if we wanted to. So remember, a chord has segments that are on a segment with endpoints on the circle. So AB is an example of a chord. We just use the segment bar on top to name it. The other one would be CD. And then notice from yesterday, we kind of talked about them. EH and EI, those are radii. A radius is a segment from the center of the circle to the outside. Okay? Chords don't go through the center. They just go through the circle. Okay? Now let's talk about some arcs. There's actually two different kinds of arcs. So let's name some. So the first one I could see is I just picked out AB. So instead of going straight, we're going to go around the circle. So it still uses the same letters, but on top we put this curved part. That's the symbol for an arc. Okay. We could also name arc CD. That means you start at C and go towards D. That's kind of how arcs work. You start with the first letter and travel towards that letter around the circle. So A, go towards B, and C, go towards D. And there's some other examples. I mean, you could go B to D as an example of an arc. Now, all these ones that have two letters, we call those minor arcs. And that means they are less than 180 degrees. So remember, all the way around the circle is 360. So 180 would be halfway. So actually the arc AI, that would be a semicircle. Or it's called a semicircle because it's exactly halfway around a circle. These are called minor arcs because they don't go halfway around. Then there's ones that you name with three letters. So an example would be ADB. Nope, I can't read. Carry my own right phone here. It's ADC. And then another one I saw was, I just named it was ICB. So notice those, ADC, that means you start at A and travel towards C, but you have to go through point D. So A to D to C. So ADC, again, you start at A and go towards C, but you got to go through D also, so it goes this way. And then ICB, you start at I. We got to go towards B, but we have to also go through point C, so we're going to go this way. Those are called major arcs because they're more than 180 degrees, but less than 360. Okay? That's just some refreshers and reminders of how arcs work. Now, these theorems, we're going to get them on here, and I'm going to try and explain them, because the problems today and the work we have to do, the work itself is not very hard, but you have to understand these things in order to do the very simple work, if that makes sense. So I'm going to try and give you the background knowledge of all this, and then talk you through the problems, and then show you the actual work, because it's not very hard. Let me scoot this up a little bit. So, first thing we have is we say that two chords are congruent if and only if. That means that both of these criteria have to be met in order to say that the chords are congruent, okay? So two chords are congruent if and only if the corresponding arcs are congruent and that the chords themselves are equidistant from the center. So equidistance is a fancy word. It just basically means the same distance apart, the same distance from a certain object. So now I want to write out in like geometry speak what these mean. So for the part A, we can say that the chord AB, the length of that is equal to the length of CD. So we're saying this chord is equal to this chord if and only if these two things are met. Now we'll put this weird symbol right here. It's kind of like an arrow with two lines in the middle. That stands for the if and only if. So I'm just doing shorthand here, I guess you could say. You know what? Don't worry about what that means. So the chords are of equal length if the measure of their arc, so the corresponding arc. So look at length AB, that chord. So notice that the arc AB is associated with the same chord. It's kind of like you cut a pizza really strangely. So the chord and the corresponding arc, they share the endpoints, essentially. So the chords are the same length if and only if the arcs measure the same amount of degrees. Okay? So the chords are equal if and only if the measures of the arcs are equal. And then for B, oops, I don't know why I wrote that. Let me do it up here. So again, AB is equal to CD if and only if. Now this part is for equidistant. So notice that from A to B, there's a segment going from E to F. E is at the center, and F comes and hits the chord. If that length EF and that length EG are the same, then the chords are congruent. So we say here EF is equal to EG. Okay? So both of these have to be met in order to say this. Okay? Second theorem says if a diameter or a radius is perpendicular, it's one of my favorite words to say, perpendicular, meaning they intersect at 90-degree angles. So if a diameter or a radius is perpendicular to the chord, then it is going to bisect the chord. Remember, bisect means cut in half. So it's going to cut the chord and its arc in half. So we can say it this way. If the radius EH, so I'm using the radius here, EH is perpendicular to the chord AB, then AF is congruent to BF. So that's bisecting the chord. Notice that F is on the chord, and so we say that AF and BF are the same. And the arc measure of AH is equal to the arc measure of BH. And so this arc AH is the same amount as the measure as the arc of BH. Okay. So that's the big fancy theorem stuff. Okay. And so what we're going to do now is we're going to look at some problems, and I'm no joking you. Some of these problems take literally no work. Some of them take like one step of work, and then some of them we're going to use the Pythagorean theorem. That's the three cases we look at. No work, a little bit of work, Pythagorean theorem. Using all this stuff. And I'm going to try and explain this stuff to you through each picture. So let's see what we're going to look at first. So the first ones, I was nice to you. The first two we're going to look at, literally there's nothing to do. So let's figure out why. So find the length of the segment, and we have to round to the nearest tenth if we need to. So these first two, there's nothing to do. Let's explain why. So let's look what we have. Notice we have 1, 2, 3 radii labeled for us that are all a length of 8.8. And you can't see that very well. There we go. So we have 1, 2, 3 radii that are all have a length of 8.8. And then there's this chord right here. So notice that 8 is a chord. It's a piece of a chord, actually. This chord goes all the way across the circle, like this right here. This is the chord. And notice that there's another radius coming this way, and it hits the chord, and it makes a 90-degree angle. They want to know how long that other piece of the chord is over there. Okay, so let's look back at this. This actually uses the second part down here. It says if a diameter or the radius, so we have a radius in this case, is perpendicular to the chord. Remember, perpendicular means they cross and make 90-degree angles. Then it's going to bisect the chord. So that's what we're using here, okay? What's happened is this radius has come through here and cut this chord in half. And they told us that 1/2 of it was 8. And so because of what bisecting means, the other half has to be 8. So x equals 8. That's what I mean by no work. There's no physical like adding, subtracting, or whatever you have to do. You just have to recognize that that's a chord being bisected. And so this piece and this piece have to be the exact same length. That's all you do. This next one is even easier because it doesn't even involve a chord. This X is right here. That's a segment going from the center to the edge of the circle. That's just a radius. And I told you that this that the radii are all 13. So right here, x is 13. That's it. No work to show. All right. Now let's scoot down, look at these down here. So now in these two, there's one step we have to do. You could technically call it two, depending on how you think about your work and in what process you do it. So let's look at those. So notice we have a chord here that's marked as being 14.4. We have this section right here as 9.7, another little section as 5.8, and then we have this x right here. And let me just go ahead and tell you, when if x is sitting right here in the middle, and you have this big side right, or this big segment right here, they're telling you that the x represents the diameter. They're wanting you to find diameter on this problem. Okay? So how do we find it? Well, we really can't use the chord because all we can say is that this right here is 14.4. That's not going to get it for us. Actually, you could. You could move this over here and label it 14.4. And then you could do Pythagorean theorem to find this piece of the side and then double it to get the other one, to get the full length of the diagonal. But let's be honest, we don't need to do that here. That's just too much work. Too much work. It's even easier for you. Notice that I'm gonna try. Let me do a color coding. Let's do it that way. So this one that I'm highlighting green right here, if I put those two together, that is a segment going from the center of the circle to the edge. That makes it a radius. Now, what's the relationship between a radius and the diameter? And we should remember that it takes 2 radii to make a diameter. So in other words, if we have the radius, we just double it to get the diameter. Well, the radius is this number plus this number. So here's all I said. I'm going to add 9.7 plus 5.8 together to get my radius length, and then I'm going to double that to get my diameter length. And when you type all that in a calculator, you get that x is 31. See how that's easier to do than doing the Pythagorean theorem thing? And by all means, if you want to do Pythagorean theorem on that, you can, but it would take you longer on this problem when this is the simplest way to do it. You recognize that you have a radius right here with these two pieces together. You add them up and double it, and you get the diameter length that you wanted. Okay? Now, in this one, it's even easier. So let's see what they gave us. They gave us that this portion is 6.8, this little piece right here. And that's what confused some kids. They don't know where the pieces go. So kind of look at the lengths of things. The length will give you a clue. This section right here is shorter, so I'm going to say 6.8 goes with it. This section is longer, so that's the 13.3. So look at what I'm looking for. X is right here. I want a radius. because it goes from the center to the edge. Do I already know the radius? Well, yeah, because again, we know that is 6.8, and then we know that this is 9.7. And so we just take those two and add them together. No need for doubling. That's all you have to do. So sometimes on these, you might have to double your answer to get the diameter, and sometimes you just add them together to get the radius. It just depends. Okay. Now the next ones, they're not bad. I mean, obviously they're not bad, but we just have to use Pythagorean theorem. We'll make sure we use it correctly. That could be the challenge. And we'll just use it like normal. And on this one, guys, you're going to have to round, okay? Your decimals this time will be ugly, and so we need to round. So let's look at what we know. We've got some segments inside. They told us that this section of a chord, so notice, see how I can tell that? It's going from a point on the circle through the circle to another point. That makes it a chord. So this section of the chord is 16.6. This 10.4 is a portion of the radius. I don't know the other piece, but I really don't need it. That's 10.4. Now I'm actually trying to find the actual radius. And notice that I have a right triangle here. I'm trying to find the hypotenuse, so I'm going to let this be the C. And we'll set up Pythagorean theorem. We'll say 10.4 squared plus 16.6 squared equals, I'm going to leave it as X, but if you want to write it as the C, you could put C instead. It really doesn't matter for me. Now to shorten myself some time, I'm going to type all this in separately because it's all on the same side. 10.4 squared plus 16.6 squared, 383.72 equals X squared. Now to get rid of squared, we take the square root. That's gone. So then X equals whatever that square root is. So square root 383.72. Now see, this time it's gross, and so we need to round. They told me the 10th, so I'm going to the 10th place. Look behind, that's going to round him up. So this one will become 19.6. Okay, so same thing. Let's keep going. This time though, they told me this little piece right here is 6.3. This section of the chord is X, I'm trying to find it, and my radius is 18.5. So now I'm trying to find a leg. So I always let this be the A. I always put the X first myself, but you don't have to. So X squared plus my other leg, 6.3 squared equals 18.5 squared. So X squared plus, now I have to actually type these out. So this is going to be 39.69. That's going to equal 342 point, oops, not 8, 25. All you have to do, guys, is just type those in, just like that. I'm not showing you that because I think you could do that. Now we'll have to subtract this number. So then X squared equals, when you do that subtraction, you get 302.56. Now we'll square root. So then X equals, That's a horrible x. X equals, and when you type that in, square root 302.56, that'll round to 17.4. All right, I'm gonna go through these last two a little bit quicker. Actually, I'm gonna pause for a minute. So this time, notice that I'm trying to find this side over here labeled X. I know my radius is 16.7. They told me that this portion of a chord is 14.1, but it's all the way up here. I need the one down here. Remember, you can kind of, if you want to extend this, you can. You don't really have to. But remember that if a radius intersects a chord and it's perpendicular, we have a 90-degree angle here. So those two are perpendicular. And that means that we've cut the chord in half. So if this half is 14.1, then this other half is 14.1. You just bring him down. And then use Pythagorean theorem. X squared plus the leg 14.1 squared equals the radius squared. So x squared plus, you type 14.1 squared in, it's 198.2 equals, ends up being 278.89. Subtract these two. And then x squared equals, we get 80.08. Take the square root, and then x will end up being 8.9 when you type that in the calculator. Right, last one. So now notice this one. I'm trying to find x, which is this portion right here. They told me that this side was 16.1, this leg. My radius was 18.3. Now, I don't know if the homework has this, but what they could do is they could put a number down here next to the center. Like, let's say it was 30.1 or 2 or whatever. If they put a number here in the middle, that's the number for the entire diameter. And so to get your radius, you'd have to cut that in half. I don't think you have any like that, but just in case you do, that's what you would do. And then we'll just keep doing Pythagorean theorem again. X squared plus 16.1 squared equals 18.3 squared. X squared plus, when you type that in, you get 259.21. That doesn't sound right. Hang on. Oh, that is right. Equal, type that in, you get 334.89. Double check myself. Yep. Then we'll subtract this. So x squared equals, it'll end up being 75.68 square root. X ends up being 8.7 after you round. So there you have it. That's chords and arcs. Super simple. You have your homework assignment will be posted with this. It's very short. It's only 12 problems. 4 of each kind. No work, 1 step, and the Pythagorean theorem. Make sure you get the homework done. You have the video watched, your notes taken. And as always, if you have questions, please let me know.